A visualization of the biomass pyrolysis process. Biomass storage and drying. Wooden or agricultural biomass stored in a dedicated storage facility is transported to the pyrolysis reactor via a bucket feeder. The raw biomass is pre-dried inside the feeder through the use of hot and dry air flowing in the crossflow. Biomass pre-drying has a positive impact on the reduction of the moisture content inside the process material by a few %, and additionally increases the pace of the processes occurring in the following stages. Biochar production. Pre-dried and preheated biomass then goes to the pyrolysis reactor, where the following 4 processes take place. The moisture evaporation process. All the moisture accumulated in the raw biomass has to evaporate in order to initiate the carbonization process. Depending on the type of biomass and the amount of moisture accumulated in the process material, it can take from several to more than a dozen seconds, and its efficiency is due to the high temperature in the upper part of the reactor. The degasification process. In the next stage, the biomass is degasified in the temperature range of 370 to 400 degrees centigrade, within which range the removal of volatile particles is most efficient. Chemical compounds like nitrogen, carbon monoxide, carbon dioxide, hydrogen, and others are flammable, and approximately 40% of the energy yield is consumed by the pyrolysis process. After mixing with the humid air from the preceding process, the remainder of those gases can be used for energy. The carbonization process. Dried and degasified biomass is treated with high temperature. This process results in the quick concentration of elemental carbon and the disappearance of the fibrous structure, improving its grindability. Depending on temperatures inside the reactor and the duration of the carbonization process, the ready material can have a calorific value in the range of 21 to 29 megajoules per kilogram. The cooling process. The ready material is cooled to ambient temperature with the use of the cross-flow water cooler. In the next stage, carbonized biomass is loaded to big bags, pelletized, or transferred directly to the boiler. Heat generation. The flammable gas has a relatively low calorific value, so the best way to make use of it is by conversion to hot water. Pyrolysis systems with productivity from 300 to 1,000 kilograms per hour can supply district heating networks with a maximum capacity from 1 to 3 megawatts respectively. The yield of flammable gases depends on the type and quality of the processed biomass and the expected characteristics of the carbonized biomass. In order to maximize the efficiency of the pyrolysis process, hot air taken from the coat of the reactor is used in the biomass pre-drying process. Hot air is transferred to the bucket feeder, which was illustrated some time ago. At the end of the process, all gases are mixed and emitted through the common stack.